Hello, the Math Dog here. This video is titled Deriving the Formula to Find the Max-Min Vertex or Vertex of the Quadratic Function f of x equals ax squared plus bx plus c, where we're only dealing with real roots. This does not involve calculus, where you could take the derivative of the function to find the max-min, and a calculator is recommended for the practice problem that I give at the end of the video. So recall you have the quadratic function or second degree polynomial function ax squared plus bx plus c, where a is not 0, because if a is 0 you don't have a quadratic function anymore, you just have bx plus c, which is linear. And then b squared minus 4ac has got to be greater or equal to 0, because if it's not, you would not have real roots, you would have imaginary complex roots. So roots, again, reminding you, are also called zeros, solutions, x-intercepts. So the real roots that we would get from this equation using the quadratic formula are as follows: negative b plus the square root of b squared minus 4ac over 2a, and negative b minus the square root of b squared minus 4ac over 2a. So here is a sketch of a parabola, which is what a quadratic function graphs like. So you have two roots. It's possible you could have what's called a double root, where you just touch the x-axis like that. This would be relevant. This video, what I'm discussing this video, is relevant if it's a double root. Let's just say, and if it is a double root, the b squared minus 4ac will just reduce to 0. But back to what I'm trying to say here is, so you have two roots. They're called zeros because they intersect the x-axis, and the x-axis is the equation y equals 0. That's one reason. That's why they're called zeros. So the coordinates of the roots are going to be negative b plus or minus square root of b squared minus 4ac over 2a, comma 0. Negative b minus the square root of b squared minus 4ac over 2a, comma 0. So it could also, these could be interchanged right here. This is the smaller, this is the root to the left, and this is the root to the right. But these could be interchanged. It all is going to depend on the values of b, a, and c. So b squared minus 4ac is called the discriminant. If b squared minus 4ac is less than 0, then we have imaginary roots. Imaginary roots do not cross the real x-axis, so this lesson does not apply to that situation. And I'm actually though going to give an example of why it does not apply to this situation. So suppose we have the quadratic function f of x equals x squared plus 6x plus 10. So in this case you could put a 1 there. So a is 1, b is 6, c is 10. So now let's apply the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So then we just plug these numbers in. So x is going to be negative 6 plus or minus the square root of 6 squared minus 4 times 6. I'm sorry, a is 1. This is 4ac. So times 1 times 10 over 2 times 1, which gives us negative 6 plus or minus the square root of 36 minus 40 over 2. So we have now negative 6 plus or minus the square root of negative 4 over 2. So this is not a real number here. So if you've seen this, remember that we define I to be the square root of negative 1. So this is an imaginary number. So this is negative 6 plus or minus the square root of negative 1 square root of 4. I can write it like that, over 2. Well, then that's negative 6 plus or minus, replace square root of negative 1 with I. Square root of 4 is 2 over 2. So negative 6 plus or minus I times 2 over 2. I can divide 2 into everything here, so that's negative 3 plus or minus I over 1, which is just negative 3 plus or minus I. So that is the solution. This is a complex number. It's not real. So now let's go to our graph. Let's try to graph this now, I should say. So I'm going to graph this by completing the square. This is the function I just worked on over here on the previous page. So I'm going to complete the square. To complete the square, what I do is I look at this term here. I have to have a coefficient of 1 on x squared. I take half of 6, which is 3, and then I square it, which is 9. So what I do is to this function, f of x, I add 9 here, but then I have to offset that by subtracting 9 here. So then this simplifies to, I'm going to take this over here now, this is equal to x plus 3 quantity squared. That's why we do a complete the square, because we can, this is a perfect square trinomial which can factor as a binomial squared, plus 1. So I have f of x equals x plus 3 quantity squared plus 1. So from, this is a quadratic function in vertex form, so I have a video on translations of functions, or I have several videos on those. So here, this actually is going to be a shift left 3 and up 1. So the graph is going to look like this. It's because the coefficient of x squared is 1. When the coefficient a is greater than 0, the graph goes up. When a is less than 0, the graph will go down. So I'm just going to plot a couple points here. Go 2 over, 4 up. Two left, 4 up, and I could go 3 over 9 up, which would put me here. So the bottom line is this parabola, which is the graph of the quadratic function, never crosses the x-axis. It does not have real zeros, so we can't use the method that I'm about to show or derive in this situation. So that's why the discriminant b squared minus 4ac must be greater than 0 for this to apply. Alright, so if the function f of x equals ax squared plus bx plus c has real roots, then the maximum minimum vertex of the function is going to be negative b over 2a, and then the function evaluated at this negative b over 2a. So remember what I said earlier. So in the quadratic function, if a is greater than 0, it opens up. If a is less than 0, the parabola opens down. So I've sketched a function f of x that has real roots. So the roots are here and here. These could be interchanged depending on the values of b, a, and c. I mean, this could be plus over here, it could be negative over here. But the bottom line is I have 2 roots. And then this is my axis of symmetry. Here, in a quadratic function, it has an axis of symmetry along has a vertical axis of symmetry, because if you reflect the right side, it becomes the left side. And if you reflect the left side, it becomes the right side. Okay? So what I'm going to do is I'm going to average the roots, because the averaging the roots will put me right here for an x value, and my vertex max min, in this case it's opening upward the way I've shown it, the max min will be right here at my vertex. And my vertex is going to be the average, the x value of that vertex is going to be the average of these 2 roots. How do you take the average? Of 2 things, you add them together, divide by 2. So that's all I'm going to do here. So I'm going to take the x-coordinate, negative b, minus the square root of b squared minus 4ac over 2a plus negative b plus the square root of b squared minus 4ac over 2a. Alright, now I need to divide everything by 2, because that's how you average 2 numbers. You divide by 2 after you take the sum. Alright, so now I'm going to write the numerator. This expression here I'm going to write as one expression, or I'm going to break it up. Everything's over 2a. I'm just going to write it as individual fractions over 2a. This would be minus b over 2a here, plus square root of b squared minus 4ac over 2a. Alright, well, if you notice now, these are opposites, so they cancel out. And I forgot, this is over 2 still. So let me fix that. It's all over 2. Fraction bar means division, don't forget that. So now this is negative b over 2a minus b over 2a is negative 2b over 2a. And this shouldn't be 2a here, this should just be 2. Just copying this. So this is all over 2. Well, this is the major fraction bar here, and this is actually 2 over 1. And remember, this means division. So this means division. So this is negative b over 2a. This is negative 2b over 2a. And we can reduce that to just negative b over a. So I have negative b over a all over 2 over 1. But this means division. So this is negative b over a divided by 2 over 1. But remember from division of fractions that you change that to multiplying by the reciprocal. So this is negative b over a times 1/2, which gives us our result, negative b over 2a. So my final result here is my min-max, which is also the vertex of the function, is going to have coordinates negative b over 2a and then f of negative b over 2a. Now you can plug b over 2a, negative b over 2a into the original function here, but that's a kind of complicated result to remember. Negative b over 2a is simple to remember. So the vertex coordinates again, which in this case the way I've drawn the function is a minimum, but if it was going as a maximum, it's the same thing. These coordinates will be negative b over 2a, f of negative b over 2a. Alright, so now we're going to demonstrate this in a problem with a projectile. So we will use a calculator to get our final answer. We're not going to find when it hits the ground here, we're only going to find the max. Because this now is negative 16, so a is less than 0, so this function, when we graph it, will look like that. So it'll have a maximum. Okay, so let's write that again so it's a little more legible. This will give us a max. So projectile is fired straight up in the air at a velocity of 180 feet per second, is fired from a height of 30 feet. When does it reach its maximum height, and what is that height? Okay, so from Newtonian physics, the position function, and when we're working with feet and seconds, the function for height at any time t will be negative 16t squared plus v sub 0 t plus h sub 0, where t is the time in seconds, v sub 0 is the initial velocity, h sub 0 is the initial height. So in our problem, h of t is being negative 16t squared plus v sub 0 in this case is 180 feet per second. So that's going to be 180t. Initial height was given as 30 feet. Okay, so in our problem, we have a is negative 16, b is 180, and c is 30. Okay, so we use the quadratic formula here. T is negative b plus, no, actually we're not using the quadratic formula because we're just finding the max height. Sorry. So all it is going to be t is going to be negative b over 2a, so the maximum height is going to be negative 180 over 2 times negative 16, which is negative 180 over 32. And since we said we could use a calculator here, that's all I'm going to do. I'm going to plug that into a calculator real quick. And I'm going to go negative, and this should be negative 32 down here, 2 times negative 16. So that should be negative 32. Let's get that drawn there. Here we go. All right, so and that's a negative divided by negative. Don't even need to put the negative signs in here. 180 divided by 32 gives me 5.625 seconds. Let's copy that. Okay, so that's my time at my maximum height. So my maximum height's reached after 5.625 seconds. Now what I'm going to do is I'm going to take f of 5.625 to get the max value. Now I'm going to use a TI-80 calculator here. You could just plug it right into the function here, -16 times 5.625 squared plus 180 times 5.625 plus 30. But I'm going to use the graphing calculator's capability here, and I'm going to plug in, write my function, -16, I use x for t squared plus 180 t plus 30. So now I'm going to evaluate the function at 5.625. So I am going to go right here, go to my y variables, and I evaluate. So y sub 1 is the same as f here, 5.625, and I get 536.25 feet is the maximum height. Okay. So this is 536.25 feet. In this case, it's a maximum, so the coordinates of the maximum are going to be 5.625, 536.25. And this is t, and this is f of t. All right, so now this is a practice problem that you can do. Stop the video after I've read through it and give it a shot, then turn it back on and I will go through the solution. So a cannonball is fired straight, cannonball is fired straight up into the air at an initial velocity of 220 feet per second and a height of 25 feet. The initial height is 25 feet. When does it reach its maximum height, and what is that height? So again, here's our position function. H of t is -16t squared plus v sub 0 t plus h sub 0. T is time in seconds. H of t is the height at time t. V sub 0 is the initial velocity in feet per second. And initial height, h sub 0, is in feet. Okay, so now stop the video, and when you're done, turn it on, and I will work through the solution, see if you agree with what I got. Okay, so in this case, I'm going to have h of t. H of t is -16 t squared plus the initial velocity this time is 220 feet per second. So that's 220t plus the initial height is 25. So A is -16, B is 220, C is 25. So the x coordinate, in this case t coordinate, is going to, of the maximum height, is going to be t is equal to -b over 2a. So we could actually write that as t max if we wanted to. Should have probably done that in the other problem. But that's just going to be -220 divided by 2 times -16, which is -220 over -32. You can ignore the negatives, so I'm going to do that in my calculator now. So I've got -220. I said I wasn't going to use the negatives, I don't need them. 220 divided by 32. So maximum height's after 6.875 seconds. Okay. So now to find the actual height, which is the y coordinate, I take the function, evaluate it at 6.875 seconds. So I'm going to do this on the graphing calculator again. Again, if you didn't have a graphing calculator, you could go negative 16 times 6.875 squared plus 220 times 6.875 plus 25. But I'm going to use the graphing calculator, so I got to change my function though this time, because now it's different. It's negative 16, and that's going to be x squared plus 220x or t plus 25. Okay, then I go back to my main screen and I am going to evaluate that function, which is y sub 1 here, which is f actually, at 6.875. And I get 781.25 feet. Get this to move down. Okay, so f of 6.875 is 781.25 feet. So my coordinates of my max, which is also my vertex, the vertex is the highest or lower point, highest or lowest point on the quadratic function, is going to be, the coordinates are going to be 6.875, 781.25. And this concludes the video. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this videos with others.